Time is money. This applies to our personal lives and even more to business, where long-running processes consume important time and are costly for the entire organization. Waiting for a long-running process to complete does not create any value, and sometimes it even creates additional cost. From a user's perspective, these are the moments when you just want to end the waiting. And like here, that your train finally arrives. We at LS Retail follow the mantra easy, simple, fast. And I'm really looking forward today to present to you what the LS Retail team has achieved in terms of performance improvements lately. My name is Martin Kleindl and I'm a product director at LS Retail. In this webinar, I will talk about performance improvements in the area of statement calculation and posting, test results, how to set up the new features, and how you get started. Be prepared for some really positive news. The process we have focused on is one of the core processes in every retail implementation. The end-of-day statement calculation and posting process. When we look at a typical retail store, there is this common flow. The cashiers start the day and then they sell items during the day. When they reach the end of the day, the money in the drawer is counted. And the next step is to calculate the statement. Depending on the number of transactions, we might have to wait for the result. When the statement is calculated, we can enter the counted amount into the system and proceed the statement posting. Again, depending on the number of transactions, we might have to wait for this process to complete. Usually, this process runs smooth. But sometimes, problems may arise when we are using old or undersized hardware, or our SQL Server is not set up and maintained properly. Retailers that have a lot of transactions per day, for example grocery retailers, might face waiting times because more transaction means longer calculation time. Retailers that have a lot of stores which calculate and post in parallel at the same time could also face problems. In that case, the problem could be table locking issues. And why is that? Let's have a look at this example. This retailer has 3 stores and the POS transactions have been replicated to the headquarter database. In this scenario, the statement calculation and posting takes place in the headquarter database. The users in the stores start the calculation at the same time. While the calculation succeeds for the first store, it fails for the other 2. If the processes are started at almost the same time, the processes can lock each other. So the users receive a message stating that the process has been locked by another user. So they will try again and try again until they manage to successfully complete the task. This example is of course rather extreme, and this will only occur in exceptions. We use this example just for illustration. And there is already an existing solution in LS Central for that. The solution is to decentralize the process. To do that, we introduce store databases to balance the load. We replicate the POS transactions to the store database and calculate the statements there. Since the calculation now happens in separate databases, no conflicts can occur. And when we have entered the counted amounts, we approve the statement and send it to the headquarter. Further processing and posting then happens in the headquarter database. This approach exists already since a while, and it works very well. But today, I want to talk about new things. Let's start with the technical improvements for the statement calculation, which have been introduced recently. We revisited the program code of the calculation functionality and did various optimizations, especially for the handling of the replication counter field. Furthermore, we introduced in-memory calculation by using temp tables to buffer calculation results and to optimize database writes. And finally, we have enabled parallel calculation of statements to get rid of potential locking issues. We did a baseline test with the original code, and it took 48 seconds to calculate one statement. We were able to calculate one statement at the same time. If we calculated two or more, we encountered locking issues. And such tests cannot be done with the Microsoft Cronus demo database. And therefore, we built a test environment from scratch in our performance labs. This environment consists of 3 machines, all hosted on Azure. A powerful virtual machine for the SQL Server, a standard D16S with 64 GB memory and premium solid-state disks. For the service tiers, we used 2 VMs with the same specifications but less disk space. And in the test database, we created 200 stores, 20,000 items, and transactions with multiple sales per day for all of these 4 million item store combinations. For the SQL Server and index tuning, we used our LS Retail SQL Server audit toolbox and other tools, like the Perform tools from SQL Perform. But how to simulate parallel calculations for 200 users? Well, we had to build our own test tool, which supports semi-automated runs and load balancing across multiple service tiers. In this test tool, we can define workflows, like in this example, where we reset the statements and transactions and then calculate statements across the service tiers, and each service tier here calculates for 100 stores and 10,000 items. This tool also supports scale tests, and here we spin up background processes via program code that run and calculate in parallel. And then we measure the behavior of these simultaneous tasks to learn how many we can run in parallel. When do we get optimum results, and when does the system get overloaded and our performance is degraded? So let's come back to our statement calculation test run. The original code took 48 seconds per statement, and the improved code takes 14 seconds. I repeat, 14 seconds, and this is a reduction of 70%. Now, I would really love to see your faces. To be honest, this was more than we have hoped for. So let's have a look at the parallel processes. Originally, we could calculate one statement at a time. And now we can go up to 195 parallel statement calculation. This might vary depending on the test environment, but it is a clear indicator that there should be no locking issues anymore. When we activated a second service tier, we could reduce the calculation time by 14%. So, multiple service tiers help, but the big benefit comes definitely from the code improvements. But we were hungry for more. And therefore, we also introduced a new process for the statement calculation. So please, let me introduce to you the incremental statement calculation. The idea of this new process is to save time by spreading the calculation workload across the day. While our cashiers are selling items and create POS transactions, we start already to create and update the statements. A scheduled batch job is running in the background, for example every hour, and updates the statement for you. When we reach the end of the day and calculate the statement, only the transactions that have been created since the last calculation run will be added. So, if our store closes at 9 p.m. and the last automatic run happened at 8:30, then our last calculation will consider just the last 30 minutes. And this will be lightning fast. So let's have a look how to set this up in LS Central. So let's have a look how to set up this in LS Central. We need to activate the incremental statement calculation for the stores. And this field can be found in the fast tab statement closing. One statement per day has to be activated, and then here this is the field, automatically calculate statement. So when this is activated, this store is considered in the incremental calculation run. There is another field, group by staff POS terminal, and I will explain that a little bit later. So let's create some POS transactions, and I will run our POS. And first I log in as cashier 45 and sell a laptop. The customer is paying in cash. Then I log off, and another cashier 46 is also doing a sale. So this cashier is selling the towel Linda. And again, paying with cash. Okay. So let's go back to the back office. So we have created POS transactions, and now we would like to calculate that. When I look at the open statements, then I see there are no statements yet. So let's go to our scheduler jobs. And here I have created a job statement calculate incrementally. And when we look at the details, then we can see that this is calling this code unit called LSC statement auto calculate. So let's run this schedule job directly. It says successfully. And now when we look at this open statement list, then we see it has created one statement. And if we look into the details, then we see here our two cashiers that did a sale. So let me clear this statement and also delete it. So we are resetting the result, and let's revisit our store setup once more. So I mentioned this field group by staff POS terminal. So if I activate that, what will happen? If I rerun our calculation job, then it will calculate and create the statements once more. But if I look at it now, then we have received two statements. The first statement is for cashier 45, and if we go to the next one, then it's for 46. So this field defines if we get separate statements created based on the staff or the POS terminal number, or if it's all combined into one. So it's really totally easy. It's just two fields to set up on the store card, and it's a new scheduler job, and you would just run it according to your business process. So let's go back to the presentation. Now, let us have a look at the improvements we did for statement posting. Similar to the statement calculation, we did code optimizations and applied in-memory calculation. It is important to know that the posting process consists of two sub-processes in the program code. First, the LS Retail code, where we do calculations and checks and aggregate data. And secondly, the Microsoft code, where the journals are posted to update stock and general ledger. Of course, we have improved the LS Retail code only. The original code to post one statement took 80 seconds, and we could only post one statement at the same time. With our improvements, we were able to reduce the time to 50 seconds, which is a fantastic 37% reduction. Furthermore, we could post 45 statements in parallel, indicating that there are no locking issues anymore. While this is already a really good improvement, we decided to go even further. We looked for possibilities to improve existing processes. I am quite sure that most of you are familiar with our batch posting functionality. The idea behind this is the following. When you post a statement, this is not done interactively. Instead, the statement is added to the batch posting queue, and the process ends for the user here. He does not need to wait for the successful posting. The batch posting engine will pick up the statement from the queue, post the statement in the background then. As of today, the batch posting engine posts the statements in order of arrival, one by one, sequentially. And this is what we have improved. With the recent release of LS Central, version 17.4, we introduced the parallel posting of statements with batch posting. In our old approach, we processed one statement after the other, first calculating and preparing, then posting the journal. In our new approach, you can define how many statements you want to post in parallel. In my example, I have selected 3 parallel threads. The batch posting engine spins up background sessions with the start session command. And while the LS Retail code now runs in parallel, the Microsoft code does not. So there is some waiting time for the posting processes. And in total, it is faster than posting in sequential mode. But you cannot just divide it by 3 in this example. When all the statements are posted, the engine will pick up the next 3 statements and continue from there. Of course, you can go beyond 3 parallel processes. The higher the number of parallel processes, the higher the throughput. But the wait time for the last statements will also grow, and you could run into timeout issues. No worries. If the posting of a statement fails, the engine will pick it up later and retry. There is no golden rule for at how many parallel threads your server will provide you the best results, because this depends on your server's configuration and capabilities. We had tested this already in our performance labs, when one of our customers agreed to test this improvement in their environment with their data. And this customer is Family Mart. For those who do not know Family Mart, this is the world's second largest convenience store chain. They have more than 40 years of experience in that industry and operate over 17,500 stores across various markets. We did this test with Family Mart Malaysia, who runs more than 200 stores with really high traffic at peak hours. And these stores can be found in malls, at gas stations, and as separate stores. Beside the stores, they have an e-commerce mobile app and home delivery for their variety of convenience items, delicious fresh food, hot snacks, as well as coffee and bakery. As I said, we did this test with their data in their environment, using a 2 terabyte database with 200 plus stores and 6,000 plus items, and massive sales history and posted entries. We and Family Mart were really curious about the results, and today I am pleased to share these results with you as well. We measured the total posting time for 100 statements coming from 100 stores, and each test had been run multiple times, and we used the average of the calculated results. The original code needed 250 minutes for all statements, or 2.5 minutes for one statement. Then we ran the same test with the improved code, but still in sequential mode. And this took only 113 minutes, which is a reduction by 55%, which means we could squeeze the time to less than the half. And then we started adding parallel processes. With 2 parallel processes, we did not see much improvement, so we continued, adding more parallel threads, and we achieved the best result with 16 parallel processes, which gave us an additional 17% reduction, leading to a total reduction of 72%. When we went further and tried with 18 and 20 parallel processes, we reached the service limits, and locking and timeout started to appear. So let's sum this up. 55% reduction just with code improvement, 72% improvement with parallel processing and the code improvement. And now let me show you how you can activate this in LS Central. In LS Central, we need to activate the store that it considers batch posting. And this is done in the fast step statement and closing, where we can activate this use batch posting for statement field. When we have done that and go back to our open statements, then the following will happen. When we now post the statement, it will not be posted, but instead it will be put on the batch posting queue. So let's do that for the first one and also for the second one that we have here in our list. We can also look up this batch posting queue by searching for it. So here under batch posting waiting, we will now see that we have 2 statements that are waiting to be processed. And how can we turn on the parallel batch posting? This is done on the batch posting setup. So in batch posting, there is this new fast step statement closing, where we can enable the parallel posting, and in the field number of parallel sessions, we can define how many processes should be processed in parallel. So this is very easy. So we need to activate it on the store, and then in the batch posting setup, we just define that we want to post in parallel and how many parallel processes we would like. So let's go back to the presentation. So let me sum this up for you. Statement calculation is now 70% faster, and we've added a new process to incrementally calculate statements, which allow you to balance the load across the day. Statement posting is now 55% faster, and the improvement for the batch posting functionality led to a reduction by 72% in our test runs. And finally, I want to share performance improvements by Microsoft. The posting of background document batches is now 40% faster in the latest release. So, how to get started? All the shown functionality has been released with LS Central 17.4 in March 2021. If you are running LS Central on SaaS, you are lucky because you will get all these improvements automatically. If you are running on an AL-based version, which is version 15 and onwards, just download the latest release from our partner portal and try it out. If you are running on a CAL-based version, which is version 14 or earlier, you can reach out to the LS Retail technical support team and request a CAL-based object package. This package is based on version 14.3 and you can downgrade it to whatever version you need, test it and implement it. If you apply these improvements, please give us feedback. We are really interested in hearing your success stories. As mentioned before, performance depends on a lot of factors. For a fast and performant business solution, we need to have the foundation in order. And this includes hardware, operating systems, SQL Server, and services. The LS Retail consulting team offers support on different environment reviews. This can be the solution architecture for service tier servers or other application servers, but also data flows, web services, and replication. We also do SQL Server audits with our own performance toolbox. And here we check the configuration, maintenance jobs, and detect performance issues. These reviews give indicators for hardware sizing and bottlenecks, software configuration and bottlenecks, and also provide best practices guidelines. If you are interested in that services, reach out to your LS Retail partner or contact our LS Retail consulting team directly for these services. We started today with this picture from a train station, which captures this feeling of waiting. To wait for processes to complete. Let's stop the waiting. Don't miss the train and get the latest improvements for LS Central to make sure you get the maximum out from your retail solution. Thank you very much for attending this webinar. We are looking forward to seeing you in our future events and webinars. Thank you very much. Have a great day ahead. Bye bye.